Now that we've covered how to predict the charge that an ion will have, we want to move into talking about naming ions. When it comes to naming ions, we have different rules for the cations and the anions. So first we'll talk about cations because they're more simple. And really, you just, for the most part, just take the name of the atom. So K+, that would be potassium with a +1 charge. We just call it potassium ion. So one of the things to note, because it's called potassium, because we know potassium is a metal, based on its location in the periodic table, when you say potassium ion, you're inherently implying that it's a cation. You're communicating that information, so you don't need to say potassium cation. You can, but potassium ion says the same thing. Additionally, these three metals, potassium, barium, and aluminum, are all fixed charge, right? Potassium's in group 1A, barium's in group 2A, and aluminum is just a fixed charge metal. So what that means is when you say that it's potassium ion, the person who you're talking to can look at the periodic table and predict the charge. That's why we don't say, you don't have to say potassium +1. You can just say potassium ion. Based on its location on the periodic table, whoever you're talking to can interpret or infer that it's a K+. When you're writing the symbol, you would still use the entire K+, only when you're talking about it. If you just wanted to say potassium ion, or if you're writing out the words, if you want to use the actual English name, it would be potassium ion. So that's for our fixed charge. When we have variable charge cations, which is again most of the metals out there, we do need to include information on the particular charge. So say for copper, it can be either Cu+ or Cu2+. Both of those are possibilities. We would call them either copper 1 or copper 2. And we use the numbers, we have Roman numerals in parentheses right after the name of the atom. But, you know, one of the things you'll note is that we don't say copper plus in here, right? We just use just the 1 or just the 2. We don't have anything about it being +1 or +2 because copper's a metal. So because copper is a metal, we can infer that that has to be a cation. So it has to be a cation. So we know if you just say 1, it has to be +1. If you say 2, it has to be +2. Same thing with iron. You can call it 2 or 3. We know what that is. When it comes to anions, we do something a little more. With anions, we take off the end of the name of the element and we replace it with IDE. So hydrogen, for example, we take the hydr and then add IDE, becoming hydride. In most cases, you think of like fluorine, chlorine, bromine, iodine. You can see you just take off the last syllable and replace it with IDE. Now, when it comes to oxygen and hydrogen, you take off the last 2. So it is a little more complicated. It's usually going to be the last 1 or last 2 what there are. Now, there just aren't a lot of anions because it's only the nonmetals. And so it's just a matter of kind of piecing which ones there are. Kind of learning those things. And a lot of these, we'll talk about these that are on here for the most part. So you'll just get kind of comfortable knowing that it's hydride, oxide, sulfide, iodide, bromide, those kind of things. One of the things you'll note is that there are no variable anions. When we talked about variable charge, it was all metals. Anions are consistent. And so you don't ever need Roman numerals with anions. When you see IDE, right away, you know that that's going to be an anion, and there should never be Roman numerals on an anion name because they are always fixed charge. They are never variable. So let's get some practice. Naming ions. Okay, so when we want the name of an ion, we want to be able to work through the different rules and go through that. And when we're naming ions, we always want to start with, is it a cation or is it an anion? Because that determines, you know, how I proceed, how I go through the naming. Do I keep the name? Do I change the ending? Those sorts of processes. You know, if it is an anion, I need to figure out the root so that I can change, just keep that and change the ending. Is it a variable charge? This would only be if it's a cation. You know, does it need a number? What should that number be? That kind of stuff. So we'll take a look. Mn4+. This is a cation, and we tell it's a cation just by looking at the charge, right? When I see that positive, that's what tells me it's a cation. I don't need to look at the periodic table or anything like that because I have the element symbol. And when I see a positive charge, that's a cation. If I want to figure out the name of this element, I do need to look to the periodic table. Mn is manganese. Thankfully, it's a cation, so I don't need to figure out what the root of this word is. I can just keep the name manganese. Okay? So now the question becomes, is this thing variable charge? For metals, which is the only place we see variable charges, when we're trying to figure out is it variable charge, generally what we look to is it a transition metal? Is it in that middle part of the periodic table? In this case, yes. I encourage you to look at a periodic table, find Mn on that periodic table. It is indeed a transition metal, which means you're going to need a number. And it's not just any number, that's where you use the 4, right? We use the 4. This is manganese 4 ion. You'll note it's not +4, it's just manganese 4, right? Because manganese is a metal, you can predict then that it has to be positive, so it would be +4. You can't predict it'll be 4. If you find manganese on the periodic table, that 4, there's no way you could predict that counting any which direction. It just is 4. All right, let's go on to F-. So we see the minus sign right there. That tells us it's an anion. Okay, so that means we don't take the name of the element. We need to figure out what the root of the element is. So the name is fluorine. The root is fluor. Okay, and then we just add IDE to the end of the name here, fluoride. So the fluoride ion is right here, F-. Fluoride, that IDE tells you it's an anion. Fluor tells you it's based off fluorine. Because fluorine is in the halogens, it's right next to the noble gases, but not quite there, we know that it's always going to be -1. It's only one column away. So when you say fluoride ion, you know that has to be -1. There's enough information conveyed there that the reader could figure out that it has to be -1. If we go to zinc, that plus, that's a cation. So again, the element name is zinc. Don't need a, there'd be no root left, it's only one syllable. Zide doesn't really make a ton of sense. So when we look at where zinc is in the periodic table, you find that it's a transition metal. Okay, so zinc is a transition metal. I encourage you to find it. It's on the top row of the transition metals. So normally we would think it needs a number, but zinc is an exception to that rule. Normally, just about everything in the transition metals gets a number except zinc and silver. Aluminum right above and over from zinc is another one that we would think is going to need a number, but it does not. Zinc is always 2+, so the name is just zinc ion because it is just known that zinc only goes 2+. So that's just one of those ones you got to learn that zinc always is 2+. So we just call it zinc. We just say it's a zinc ion because through memorization, your reader can know that it's going to be zinc 2+. Got another cation here. So I look up the element name tin. Again, you can see some of these cations, some of these metals have pretty simple names. There's no way you could take a root out of that. It's just tin. So tin's a cation. Does it need a number? Well, it's not in the transition metals, but it is a main group metals. To the right of the transition metals, down in the bottom of that right-hand side of the main group, where below the non-metals, so tin is over there, gallium, Ga, Tl, Pb. Those are called main group metals. They are also variable charges. The only metals that are not variable charge is that handful: zinc, aluminum, silver, and then group 1a and 2a. Any other metal is going to be variable charge. So this is tin 2. This is a tin 2 ion. Again, because tin's a metal, you know it's going to be a cation, but you have to tell that it's 2+. No one can predict what type of ion tin forms. You know it can be a cation, but it goes 2+, it goes 4+. You have to communicate which type of tin cation it is, so the name would be tin 2. Participation 6-4, question 5. What is the name of each of the following ions? A, K+, B, Fe3+, C, H-, and D, S2-. This is the 5th question on participation 6-4, due Thursday, June 4th at 11:59 p.m. over on Blackboard. Link to the assignment is right below the links to these videos. Again, what is the name of each of the following ions? K+, Fe3+, H-, and S2-. All right, one more participation question in this video. Only one more video left. Can't have that many more questions on participation 6-4, but we got to watch that final video to find out. I'll see you there.